Hello guys, this is a video for the Beer's Law sample data. You should have done the Beer's Law in class today. And right now I'm going to teach you guys how to construct a calibration curve. So a calibration curve is basically a graph of linear fit to help us find the unknown concentration of our Gatorade or blue Gatorade. So this is what we solve for using our absorptions that we have gotten from our our red samples. Sorry, from our red values from our Gatorade samples. Okay, so to calculate the concentration, right, we simply have to use M1V1, M1V1 equals to M2V2, right? So we use that to calculate our concentration. So to calculate the concentration, we have M1 is our stock solution, and our volume is the volume of our stock solution. Okay. Um, so um, so to do it, we simply just and this will be equal to our concentration of our M2, which is going to be solved for on this graph, on this column of the graph. By dividing by our volume of our dilute sample, which in this case we all have a volume of 60 in this case. So essentially we're making Google Sheets calculate our concentration all in one shot. So we simply just do equal to. So M1, so that's our molarity of our stock solution, which in this case, right, is this. So we could just simply just copy this, this number, or we could just click us right here. Up there, it's up. Okay. All right. How about this? I think it'd be better if we copy this value first and then press equal to this times our volume, which in this case is here. So it should be listed on this column. So we could just type in C2 in this case. C2. And then we divide that by our volume of our dilute, which is always 60 in this case, as you can see on the graph. So as we could see, right, our volume of our concentration of our water is simply just 0. But now here's a cool trick that that Google Sheets does. So if you hold this down, right, and you bring this all the way down, it actually calculates all the value for you. So you see, this is it did it for C3, which is the volume at 5 mils, and you see C4, so it did it for this one here for 10. So it calculated all our concentrations here. So now how do we get the absorption? So if we do the absorption, right, we simply use back our lab here. So to calculate the absorption, right, we do the negative log of our red value divided by the R of the red value of the stock solution. So our absorption is equal to negative log of the red value for each Gatorade sample over the blank. So to do it, we simply just do equal to log, and then we take our red value. In this case, because we have no Gatorade in our blank, so we simply just it should be this red value. So B2 divided by B2, which in this case we'll get 0. No absorption in this case. And then we simply keep inputting this formula. So equal to negative log of B3, divide that by B2. So I think this is autofills. So I'm not sure if you pull this down, it'll give you all the values here. Oh, no, don't use this one. So simply just type that in, negative log equal to negative log of B4 divided by B2, which is again, our blank. Of B5, which is that reading, divided by a blank. Oh, whoops, did I type it wrong? Typo there. So that should be our reading. And B6 divided by B2. And again, B7 divided by B2. And then finally, equal to negative log divided by B2, which is our blank again. And then we simply, when we do the same to calculate absorption of our unknown. So negative log B9, which is our unknown, divided by our blank. And as you can see, we have our all our concentrations and our absorptions. So if we want to type in what we just did, it's negative log divided by blank. Right? Want to just have that just for yourself. And then we simply just take this, right? So this is essentially what we typed in on our formulas. Okay. And now we can construct a calibration curve. So to construct a calibration curve, you hold these down, and not including the unknown, because that's what we're trying to find eventually. Then you do insert, insert chart. So chart. So you should see we have constructed a scatter plot. If it comes up to be a line graph, you don't want that. You want a scatter chart. And when you have the scatter chart, you also want to go to customize, and you want to go to series, and you want to click where it says trend line. So this is the trend line that it creates, and we'll use this trend line as the equation y equals mx plus b. And to get the actual equation, actually, it's important to click on the r value, the r squared value. So to have a good linear fit, if we get a value of 0.95 or higher, which we do, that means our linear fit is very good. And to get the actual equation, we have to go to legend. No, not legend. Label. So you want to click label under series, right? So series, and then we click label and then use equation. So that's your equation for your graph. And of course, our y is our absorption, and our x. So to calculate the concentration, well, we have our y absorption of our unknown, but we have our equation for our x. So now you would simply just um, um, solve for concentration. Hopefully this is helpful, and you could use this graph that you constructed and attach it to the lab. If you have any questions, let me know.